Hi and welcome from Fresh by Design. My name is Ross Briggs and I am the Senior Project Manager for Fresh by Design across Australia and New Zealand. Our core business is in either equipment sales or project design, development and installation. We operate around all of Australia and New Zealand with a speciality for hatchery systems, fry systems and research systems for universities and institutes. We have been asked to supply a virtual summary of our macroalgae installation for Waikato University. So we have a summary of the project from start to finish, along with a short video of the site and some input from Marie and Chris from Waikato. Hope you enjoy it. Fresh by Design is proud to announce the completion and official opening of the University of Waikato Macroalgae Research Facility in Tauranga, New Zealand. FBD was contracted by the University of Waikato to supply and construct a state-of-the-art recirculation aquaculture system for the Facility of Aquaculture Research of Macroalgae in New Zealand. This was comprised of two identical bespoke algae research systems for both freshwater or saltwater use. They were all housed in locally sourced greenhouses using reverse cycle heat pumps for temperature control. The cultivation research is focused on the development of sustainable technologies to enable the production of marine and freshwater macroalgae for biomass applications. This will ultimately deliver on New Zealand national targets to diversify the local aquaculture industry. The primary species to be grown in the RAS, and that can be seen in the photos, are the freshwater algae and seaweed ulva. Research around the uses of the produced biomass focus on the incorporation of algae bioproducts for human and animal health and nutrition, plant health, biostimulants and other materials. The project started with initial meetings and development of the scope. This involved gathering of information, mainly what was the purpose of the facility, how much stock and how much biomass were going to be held in the tanks, what was the expected tank sizing, how much flow and exchange rates did the tanks need, what nutrients additions were going to be needed, expected layouts for operational requirements and other operational requirements such as harvesting systems. It also involved some site visits and some technical workshops with the staff on site. This also involved using previous knowledge built on current systems and designs and looking to improve and simplify them where possible. We also gained valuable information around the longevity of the project and likely repurposing at a later date, so it required the ability to move all the equipment at a later date. Following the initial meetings and information gathering, Fresh by Design then start to focus more on the design requirements and layouts. For this, Fresh by Design follow our in-house quality management systems that specifically capture all of the design parameters, such as what is being kept, how big, how much stock, what are the inputs and nutrients being added, and the size of the tanks. Then we work through all the system inclusions and work through the likely design and equipment needed to develop a concept PID, which we work through with the client. We supply an early high-level budget expectations. This is important for client feedback to make sure that it is all within their expectations and to ensure major changes to the scope are not needed. We also provide early 3D visualization layouts. This allows quick and easy sizing of the system and footprint. So a summary of the system at this point was a requirement for two identical systems. For large macroalgae holding, freshwater or saltwater for either system. Freshwater or saltwater to all the tanks, including system water. There were 6 7,000 litre HRAPs and 6 1,000 litre tanks for each system. Each tank had to have the option of a static bath treatment or flow through as part of the RAS. A harvesting method was required for algae from all of the tanks. Flow control was required to all of the tanks, along with flow monitoring for the system as a whole. Intake for freshwater and saltwater was included as the saltwater was brought to site. The system was likely not going to be near the ocean. Wastewater was also going to need to be brought to the site and included and added into the tanks at some stage. And sterilisation and filtration of the intakes was required as needed. Temperature was required to maintain temperature within agreed set points. And it was agreed to use greenhouses to help maximise the water temperature where possible. And we looked at sizing these to work in and around existing tank sizes and also around existing standard greenhouse sizing. CO2 dosing was included as part of the system, along with a full monitoring package and pump control. This included sensors for temperature, pH, salinity, oxygen, flow and pressure monitoring of the filters. We included VSD control of the main pumps, and this allowed perfect feedback of pump control. After working through the concept design and general assumptions, we moved to the detailed design phase. This is where we are sure all the equipment and system specifications will be locked in with relatively minor changes. All the equipment gets detailed. All the equipment was required to be saltwater rated, and the equipment would be outside as there was no plant shed. So it would be exposed to the elements, and where possible we included protective coverings and suitable equipment and fittings, noting that UV and radiant heat from the sun is detrimental to the equipment. For the sumps, we found off-the-shelf concrete moulded tanks, usually used for wastewater treatment, and we included a heavy base to prevent the tank popping out the ground due to the low water table, heavy-duty marine concrete, and internally finished and sealed. The primary solids filters, we used Waterco bead filters and RK2 fractionators. This is mainly due to their known operational filtration capacity. Secondary solids filtration or fine solids filtration, we used AFM medias, and we used Waterco media filters to house these in. These are chosen because of their known filtration capacities. Pumps, again, we chose Waterco. They've been a great client for ours, and they're durable and price efficient. They do require some saltwater seals to be added, and on top of this we added in a variable frequency drive so that when the client changed the water control to various tanks, it gave them optimal water control to their other tanks at the same time. For sterilization, we chose UV with an optional added extra of ozone. We went with Ultra Aqua UV for this size of UV system. Monitoring and control, we usually use OxyGuard systems delivered through Technolab. In this system, we used it in conjunction with a range of Dwyer flow sensors and pressure sensors. One of the reasons we use OxyGuard is part of their project support and post and service. The equipment is easy to use and has great many options and can be changed as needed. We also look at all the technical calculations. This is boring stuff, but quite essential. This would include hydraulic design, specific sizing of all the equipment and pumps, developing the power usage guidelines for the electricians, looking at the water usage and waste production for development applications and permits, dimensions and layouts of all the equipment and tanks, and also formal CAD work. This took us to an initial formal proposal, which takes into account all the design specifications, budget expectations, operational requirements, and the client's wants and needs and comfort level. This can also have several reviews and several iterations and is quite a cyclical pattern. Ultimately, it gets down to the final site specifics. Then we work through the final layout based on the final site selection. The initial site was assumed to be fairly spacious and so had a standard layout as may expected for many RAS systems. However, the final site was quite unique. This was a triangle site with a rail track on one side, a road on the other side with access required from this, a building on the upper side. Waikato University had an office across the road where they would work out of. There was other nearby land users required access through the property, and there was a high groundwater level on the site, which we had needed to take into account for the building and for in-ground pipes and in-ground sumps. We needed to take into account also the shading effect of the existing buildings on the land. This essentially excluded, to a large degree, where we could put tanks and greenhouses. We then reiterated some of our design processes. We redesigned some of our plumbing runs and piping calculations, and there was also an effect on the elongated wiring for sensor feedback. Ultimately, we came to a final layout that was installed and that everyone was in agreement with, and that ticked all the boxes. After everything was agreed and signed off, equipment was ordered and delivered, ready for installation. This was due to start around March the 14th, 2020, which was when travel restrictions started fully due to COVID. We could not travel out of our state or to New Zealand. So, after a brief period of discussions and panic about what was going to happen, we discussed the options, and there was two main ones. One was handing over the installation to the main contractor with our help, or managing the installation ourselves remotely using local contractors. And I think we were all in agreement that this was the best option and the one that both Waikato and Fresh by Design preferred. So after a brief lockdown period, approximately mid-May, we went to work again. There was lots of social distancing and new regulations in place to deal with. We used mainly local contractors for the first time, and in conjunction with Waikato to manage that installation process. It worked extremely well using phone and video apps to see what was being installed on site and to have daily and weekly site meetings. There was good local businesses in the area who were willing and able to help, and ultimately later helped Waikato. And it changed Fresh by Design's way of thinking about our installations going forward. Having our full 3D models was essential to enable this and would not have been possible otherwise. The local contractors loved having our full CAD models available to work off of and allowed us to fully understand what was going in. Ultimately, the design is our IP. With the project due to start just as international flights were cancelled and countries started to lock down, it was an amazing effort by the university and all the other teams involved to keep the project moving and ensure it was completed once New Zealand came out of lockdown. Other key project partners included Aotea Electrical, Hawkins, Greenstone Group, Water Solutions and Technolab. A high level of locally sourced New Zealand products were used. This included all the chillers, pumps, filters, storage tanks and sumps, along with additional local installation expertise.
G'day. No, it's an international audience.
It is, isn't it? So Fresh by Design has asked us to answer a few questions about our aquaculture research facility here in Tauranga in New Zealand. My name is Marie. I lead the research program here at the University of Waikato. The program is funded by the Tertiary Education Commission and the University of Waikato. And the whole project is really about establishing aquaculture technologies for seaweed and freshwater macroalgae here in New Zealand, with the long-term goal of laying the foundation for developing a seaweed industry here. And so mainly we focusing on sea lettuce, so species of ulva to grow here in the facility, and also freshwater macroalgae for the use for bioremediation. We're also working a lot with common kelp, Eclonia radiata, and a few other species that we're putting out in here for a nursery period as well. So I'll hand over to Chris Blake to talk a bit more about the actual systems.
Hi, I'm Chris Blake, and Fresh by Design sent through a few questions, which I'll talk through regarding more on the RAS side of things. Firstly, for the research needs of the project, we needed to produce biomass on a semi-commercial scale, both for our chemical analysis and to demonstrate to our partners what a commercial scale looks like. However, we had to balance this with the site constraints of locating the facility next to our existing university buildings, which are just across the road. So RAS suited us for that reason, and so we could build it where we wanted to build it and minimise things like seawater usage, energy usage, etc. We had to put it into a flexible site in the end. We needed the functionality to run each of the tanks, which you can see something behind us, on an individual basis. So either on batch, stagnant water, flow through, fresh water, seawater, as well as RAS. We need a wide range of temperature control, flow control, and importantly, we need both freshwater and seawater capabilities in all the systems so that everything's spec for seawater, and it has been since the start.
Oh, it was great. It was so helpful. We have constant meetings and so many really helpful suggestions to with all the sort of technicalities that I didn't really know much about plumbing. I know a lot more now, and so it was really great.
Yeah, that was good, and I can add that we managed to build with Fresh by Design managing it remotely through COVID, which enabled us to probably gain a year.
Yeah.
The borders have been shut since then, and we got our research up and running, so that was great.
Yeah. Very good. Thank you very much.
Cheers.
For further information, please contact us on the emails below or visit our website at www.freshbydesign.com.au. Fresh by Design offers a full range of services to meet your project needs, and we welcome your inquiry. Thanks for listening.